And welcome back to Miss Sogram's Maths. This is a walkthrough video for the solutions to one of the D&D papers. It's the one that is on Statistically Based Reports, and it's Practice External Assessment number 6 from their booklet. I've put a link to their website in the video description for this video, and I strongly recommend you check them out. I want to say a big thank you to them for allowing me to use their resources in this way. If you don't already have a paper copy of their booklets, I highly recommend that you go and order them. It's much more useful practice for the exams to go through this on paper first and then come and watch the walkthrough video to see how you did. Okay, I'm going to assume that you have read the article for this question, which is all about house supply and demand. And question number 1 is to give one possible reason for the percentage drop that was since September 2012 in the intention of people to sell their residential property. So I'm starting off by saying that the article discusses that demand is greater than supply. This would push prices up and make existing homeowners less likely to sell. And that's because their current home's value has probably gone up as well if the whole market is experiencing this. So they might choose to stay because they've got more value in their property, but it also means that if they are looking to buy a new home, so sell theirs, they'd need to buy somewhere else, and that might be more expensive and harder to find. Part B, we need to construct a confidence interval. So the proportion that we're doing this on is 9.2%. The size of our sample is 2,148. So our margin of error is equal to plus or minus the square root of 1 over 2148. Which is plus or minus 2.16%. The confidence interval, we're going to do 9.2 take off 2.16, so 7.0% up to 9.2 plus 2.16, 11.4%. And we interpret that by saying that we can be confident that the proportion of New Zealand adults definitely looking to buy a residential property in the next 12 months is between those numbers 7 and 11.4%. Now, can a claim be made that there has been an increase in definite buying intention? So we're looking for the difference in values now because we're looking for that increase and testing that out. And then we're going to construct an interval on that. So the proportion that was in September 2015 we were given as 9.2 and November 2014 5.9. In the 2015 one we had N was 2,148 for our sample size, and we're told in the question to assume in November it's 1,850. Okay, so the margin of error for this one we already worked out on the previous question just up here, so that is plus or minus 2.2%. or 2.16, and the margin of error on this one is plus or minus 1 over the square root of 1,850, so that's plus or minus oops, didn't do the 1 divided by, here we go, now times it by 100, so that's 2.32%. So the margin of error on the difference, well, we've got 2 independent groups here, so it'll be 1.5 times the average of those two. Okay, so 1.5 times half of 2.16 plus 2.32 is plus or minus 3.36%. Confidence interval on the difference. So the difference is 9.2 minus 5.9, and then plus or minus 3.36. Okay, so 9.2 minus 5.9 is going to be 3.3. If we take off 3.36, we get our lower limit. 9.2 minus 5.9, add on 3.36. Now, this interval does contain 0, so it is possible that that difference went in the other direction, so we can't make the claim that there has been an increase. And the final part here, we're looking at the potential or a potential issue with the survey questions that asks respondents about whether they're definitely planning to buy or sell a residential property. Well, this is all about what people are planning to do, and that doesn't always come to reality. So we're going to talk about that. So I've put a bit of detail in here for that. So people's intentions don't always match what actually happens, and there could be various reasons for that. They could just simply have a change of mind, change their circumstances, the market changes, and they decide to do something different. So the real amounts of house sales could actually be very different to what was listed here as their intentions. Question 2 is about this article that's talking about people pulling sickies and also flaking out on plans. I'm going to again assume you have read this and we'll go straight on to the questions. One thing to note is this was an article from the UK, so it does talk about things like taking more time off for sickies in the winter and combining that with Christmas, but of course that's a Northern Hemisphere thing that they've talked about there. Okay, first, find the margin of error and a confidence interval using the tabulated weighted sample figures for the percentage of UK people 18 to 24 that have flaked. So we're looking at the table that's towards the bottom of that article. So the proportion we were given is 63% in that category of 18 to 24. That was stated in paragraph 2 of the flaking section. Now we need a margin of error. So for that, we're going to need our n value. We have, from the table underneath the weighted sample amount, we had 193 in that group. So then the margin of error is equal to plus or minus 1 over the square root of 193. So that's plus or minus 7.2%. Then we go to do the confidence interval. It's going to be 63 plus or minus 7.2. So if we add on, if we take off the 63, take off the 7.2 first from 63, then we'll have 55.8%. And if we add on, we get 70.2%. So then we can be confident that the actual proportion lies between 55.8 and 70.2%. Okay, for part B, the 95% confidence interval for the percentage of Americans that take sickies is given just here. We want to use the margin of error associated with the confidence interval to estimate the sample size of their survey. So we've got to work out that margin of error from 23 up to 29. Halfway between, there's going to be 26, and if you're not super confident, you can just add them up and divide it by 2. So you've got 26 is the halfway point. So we've got a plus or minus 3 on either side. So the margin of error is equal to plus or minus 3%, because from that middle value of 26, it's gone either way by 3. Now, margin of error is worked out by doing 1 over the square root of n. So that's going to be equal to 0.03. Remember to do that as a decimal rather than it just being 3. So now we can solve this. So 1 over 0.003 is going to be equal to n, square root of n. So n will be equal to that answer squared. So let's do 1 divided by 0.0. Oh, I put too many zeros in there, didn't I? There we go. 3, and then we square that answer. So we've got 1,111. Right, for this question, we've got 19% of all workers pulled a sickie in the last 12 months, and we want to work out what percentage of the workers were in the 40 plus category pulling the sickie. Okay, so we're going to get some information from a couple of different places in the article. We'll start with 19% of all workers. In the weighted sample. So in the weighted sample we had 1,625 equals 0.19 times by 1,625 means we've got 308.7 that took a sickie. Now I know we can't have 0.75 of a person, but we're going to work with the maths of it rather than round that up to a whole person. Then in the 4th paragraph down from the sickie section, we're told that 28% of 18 to 24-year-olds took a sickie, and 23% of the 25 to 39s. Okay, so in our age 18 to 24, we've got 193 people in the sample. So 193 times by 0.28. So 0.28, times 193, that's 54.04. Remember, we're working in weighted numbers here, so we don't need to round them to whole people as well. So 0.23 times by, so the number of people we had in the 25 to 39 category, let's just look for that, is 411. So that's 94.53. So then aged 40 plus has got to be 308.75 minus those two to see what's left. So that's 160.18, and we need to now turn that into a percentage. Now the percentage we want is what percentage of workers aged over 40 took the sickie. So now we need what's the total of people that are over 40. So we've got 160.18, and then in our table of weighted samples, we've actually got two that count in the category as being over 40. We've got 40 to 59, which is 556 people, and then 60 plus is 465. So we need 160.18 divided by 556 plus 465, and then times by 100 is 15.7%. Okay, why do the answers from each age group not total 100% when we look at this question? In the past 12 months, have you done any of the following to get out of going to work? So we're directed to look at the bit that's shown after the report. It's that little table underneath the weighted sample section. And we can see that some of the totals for those age categories add up to more than 100% and some are under. So it means it's because that question was worded to select all that apply, so they could actually answer, they could tick responses for more than one of those options, and they also, for the ones that are under 100%, they wouldn't have answered the question at all. And then comment on the effect of the not applicable response to the question and how this could be minimized by refining the sample frame. Now, this is particularly evident if you look at the older category, so those that are aged over 60, there's 65% that tick not applicable because they've not worked in the past 12 months. That would be because a lot of them would be at retirement age. And so we could adjust the sample frame to only pick people that are in employment, because that's actually all that we're interested in, is where they're not going to pull sickies if they're not in employment. So let's just look at those that are employed. Okay, we're on to question 3, where we have an article about a study that was done on the impact of sleep and your immune system, or particularly getting a cold. And I will leave you to read that. As usual, it's pretty gross about measuring mucus production and so on. Okay, so let's explain whether this study is an observational study or an experiment. This one is an experiment because they deliberately took people into a controlled environment and applied the treatment that they were going to receive and measured the outcome. It wasn't observational of what was already happening within their lives. Okay, now we want to identify and describe the explanatory and response variables. So the explanatory was how much sleep they had. That was the variable that they controlled, and then they gave them the virus, and response was whether, how likely they were to pick up the cold. And I've put that as the measurements that they actually took to measure whether they had symptoms of a cold. So those things that they talked about of how much mucus production, etc. For part C, the researchers calculated their nightly sleep according to how much movement they had. So it was the time that they were asleep minus any time that they were moving, assuming that movement meant that they were awake. And there's a potential flaw there, because people can just be really active in their sleep and not actually be awake, but be rolling over or moving about just a little bit within the bed, but still asleep. So that means that some of our participants would have had a lower number recorded than what they actually slept. Okay, why did researchers remove participants from the study if they showed high levels of the rhinovirus antibody? So this would show that they already have some pre-existing levels of that antibody that protects against the common cold. So it wouldn't be a good measurement to have in there. It introduces some bias that they're less likely to pick up the cold anyway, and we're not really going to see the results of the treatment that we're trying to apply of how much sleep they're getting. Okay, and the last question, the purpose and role of the control group here. So we know that anybody could pick up a cold, whether you've had sleep or not. So we want to see what the expected rate of infection would be just on a regular group of people that we're not controlling for whether giving them the cold or not. They could just pick up a cold anyway. So then we can accurately compare the likelihood of picking up a cold when we changed how much sleep they got, so that we'd have this normal, in quotation marks, group from the control group there. Okay, that brings us to the end of these papers for statistically based reports. If you found this helpful, please interact with the video. I do like to see the comments and hear back from you guys, but also if you do that, it helps other people to find it as well. And if you found it helpful, I'm sure that it would be useful to others too. So I'd appreciate your interaction there. Thanks very much. And if you need any more help on anything level 3 statistics or calculus, check out my homepage. I've got lots of resources to help you there, and I will see you next time.